Okay, ready. Top prime, 2. Multiply by the denominator, 3x plus 5 minus. Top, multiply by the denominator prime. Very good. Over 3x plus 5, everything squared. Do we understand this? One more time. Let's do it one more time. So I have the first function prime. Well, the derivative of this is 2. Then I copied the second function, which was 3x plus 5. Then I got to the negative. Then I copied the top. And then I differentiate the denominator, which is 3. Of course, you can write it in the opposite order, 3 times 2x minus 4, if that's what you want. And the denominator is squared. Okay, we have to try to simplify this as much as possible. So what will I have to do next? Anyone? Excellent. Next step. Final step. So 22 over 3x plus 5 squared. This is how we apply the quotient rule. Any questions on the quotient rule?
Yeah, where did,
Yes.
yes. Where did 4 go?
You mean this 4?
Hold on.
Are you talking about this one?
No, I noticed where it went.
I'd rather go back and check if you have any doubts.
No, I know where it went, but now where did the 3 come from?
Okay, so let's do this again. So we are differentiating a ratio, right? So I have to use this rule. We proved it. I'm not asking you to prove it. I just wanted one time for you to see it. It's one proof. It's not the only one. So we differentiated the top. That's what this is, the top function prime, okay? So the derivative of this is 2. It's a sum or a difference of 2 functions. When I differentiate a constant times a function, constant x prime is 1, I get 2. The constant prime is 0. So this piece is this. Then I copy the second one, which is the bottom, and I copy 3x plus 5. So this piece is this. Then I have minus. Then I copy the function from the top, which is here, is this. Then I differentiate the denominator in the same way I did with the numerator because it's a linear function. The slope is 3. Or if you want 3 times x, x prime is 1, 3, the derivative of 5 is 0. So that's how I get this to be 3.
Okay.
Is that better?
Kind of.
Which part is not clear?
I still don't understand where the 3 comes from.
This one?
Yeah.
Okay, so let's differentiate 3x plus 5, right? So we know that this is a function f and this is a function g, and I can write 3x prime plus 5 prime, right? We had, where's my handout? We had this rule, the sum or the difference. So f plus g prime or f minus g prime is f prime plus or minus g prime. If it's plus, it's plus. If it's minus, it's minus. Correct so far? Okay. So now I'm asking myself, how do I differentiate this? Because this is a constant times x prime. And I have a rule for that too. A constant times a function prime is c times f prime. So this is 3 times x prime. A constant prime, we know it's 0. A constant prime is 0. So this will be 0. This is 1. So 3 times 1 is 3. So the derivative of this is here, and it's 3. And the same thing with the derivative of this, which is here, and it's 2. Just look at the another way of looking at it is 2x minus 4. The slope is 2.
Okay.
So the derivative of this linear function is 2. With the other one is 3x plus 5. The slope is 3. So the derivative of this is 3.
Okay.
It's a constant. Rise over run. Is that better?
Yes.
So, and then we distribute it. We remove parentheses, combine like terms. I have 2x times 3, which is negative 6x, and I have negative 4 times 3 with minus in front, which is positive 12. The 6x with negative 6x go away, 10 and 12, 22. Is this better?
Yeah.
Everyone? Are you okay? Everyone? Okay. Okay. Obviously, this we cannot solve or find the derivative as is. We have to use our contract. Let me just get it started. We're not going to do it. I can let you do it. So what is our contract? What does our contract say from the first day of classes? We have a contract that never expires. Can anyone tell us what is 6 minus 5x squared squared? Which is very good. Say it again. Minus? Very good. Excellent. And plus? Very good. So please remember we have an agreement on a binomial squared, and that agreement is forever. Okay. Anything else? Okay, let's go back. We're trying to identify the derivatives of exponential functions now. So we are trying to figure out what this is. Okay, so let's start with the definition. This time, we don't have anything else, nothing to think about it, in the sense that we haven't looked at something like this before. This is the first time. So let's approach it with a definition. So can anyone tell me what to write? Very good. Age approaches 0. Very good. Of what? Very good. Very good. That's it. Okay. Is this correct? Is this the definition of the derivative? In this case, we are looking at a to the x. Perfect. What now? Allow me to suggest. But I have to ask you a question first. Let's say I have 2 to a plus b. Where does this come from? Right. I can get away with anything in this class. Thomas is on the case. Yes, that is it, right? So when we multiply two exponential notations having the same base and different exponents, we copy the base, and what happens to the exponents? What did we do? What did we do to a and b? Add them, right? Good. So now, obviously, this comes from something similar. Can anyone help? So this is limit as age approaches 0 from... Please use this property and tell me what to write. Yes, Tony?
A to the x plus a to the h minus a to the x.
Careful.
Oh, multiply each other.
Ah, very good. So we have a to the x multiplied by a to the h. Do we all agree? Because we copy the base and add the exponents, correct? Okay, very good. What do you think I'm going to do next? And remember those two key words that we talked about over and over. What are those key words? Factor simplify, that's it. So which one is it now? It's not the simplify. There is nothing I can do to simplify, but I can factor. What will I factor out? Look and tell me, what can I factor out? Say it again. A alone is not a common factor. A to the x. Very good. Excellent. So a to the x. Tell me what is left in parentheses. Excellent. Wonderful. Very good. So here's a question now. the variable in this problem? Look carefully and say the variable is, because I see 3 letters. I see A, I see X, and I see H. But only one of them is the variable in the problem. Exactly. Only H is the variable in the problem. A is a constant. It's the base of an exponential function. X does not have anything to do with H. So there must be a constant here then that I'm getting at that I can pull in front of the limit. Which is the constant that I can pull in front of the limit? Which has nothing to do with H. Say it again. Exactly. Very good. Good. So now I would like to do this and see what this is. Oh, I hope I'm not disconnected or whatever. Please. I have to ask you to be patient for 1 second, and I'll show you what I'm doing. Because I have to send a test to Hawaii. And here's the test. Okay. Yes, you may. Okay, I have to send this test to a student who's taking my test in Hawaii. So I'm going to do this because she's in my online class. And is the test there? Yes, it is. Okay, sorry about that because I don't want them to wait. She's 2 o'clock there. She's taking it at 2 o'clock. I missed 6 minutes. Okay, I hope they get it. I put this up here so I don't forget, but I didn't look at it. So what's the use of that? Why can't I? Okay, that's it. Now I would like you to give me the syntax for the limit. I want to determine, here's where I'm at, here's what I'm doing. I'm trying to determine this limit using Maple. So I want your syntax for the command for limit. I'm waiting. Yes, limit. So first of all, remember what we're trying to do. One more time. I'm trying to determine this limit. I want to see what Maple tells me about this limit. Limit as h approaches 0 from a raised to h minus 1 over h. I want to see what that gives. So, parentheses for the top. Oops, not that. This one. Oh, I'm sorry. I thought I did. Sorry. So parenthesis a raised to the h minus what? Minus 1, close the parenthesis, divided by what? H, comma what? H, exactly, close the parenthesis, semicolon. We know that, right? And I press enter. Look at that. What if I change A into 2? What do you think the answer would be before I click? Right. What if I change it into E? What should I get? Okay, how much is natural log E? So let's come back and make a decision then. What is this? What does this equal to? What was it? Natural log A. That's the derivative of a to the x. So a to the x prime equals a to the x times natural log a. Let's put it in on the handout if you want. And now I would like you to tell me what e to the x will be. Which is 1. That's it. That is it. Any questions? So please put it in. It's a to the x times natural log a. E to the x prime is e to the x. So let's verify what this is. Then we already have it. We already showed it. Can anyone give us, so therefore E is a number such that, what does this equal to? We just determined a second ago. What was it? When we replaced A by E, what did we get as the answer? Which is? Exactly. So therefore E is the number that satisfies this condition. E to the h minus 1 over h, and the limit of that expression, and it's 1. So now we know. Moving on. Yes, finally we can do G. So G prime. So we have f of r equals e to r plus r to e. And then we can move on. Okay, so I'm asked to find f prime of r. Which is the variable here? Of course, of course. So I'm asked to differentiate the sum of two functions. And how do I differentiate this? What about e to r prime? E to r plus. Now this is r raised to a constant. How do I differentiate x to the 5th power? I differentiate r to the e power. I have to bring e down times r. Don't forget to subtract 1 from the power. So what will be the power? E minus 1, indeed. This is it. This is it. Very good. Next, other applications. Any questions so far? Yes, Tony.
Where did the e times r and the e minus 1?
Very good. So how did we differentiate x to the nth power? That's okay. We brought down n and we multiplied by x and subtract 1 from the power. So I brought down the constant, which is e, and I subtracted 1 from the power. Any questions? Any questions? Okay, very good. So now let's look at applications. So let's look at applications of all sorts. We have all sorts, velocity, acceleration, everything that we need from these two sections. I still have time. Yes, yes, yes. Okay. Suppose that f of 3 is 4, g of 3 is -1, f prime of x is 2, g prime of x is 5. Use the product and quotient rules to determine fg prime at 3 and f over g prime at 3. If I ask you, I come to class today and I say find h prime of 3 or h prime of 7, what would you say to me first? I come in and I tell you find f prime of 3. What would you say? Give me the function, right? If I come in and say, hey, let's find f prime of 3, what would you say? Wait a minute, you haven't given me the function. Give me the function. I'll find the derivative, and then I will plug in the derivative what? Right. So I can't find fg of 3 prime, fg prime of 3. I can't. I can't find f of a g prime of 3 unless I have what first? I have to have fg prime of x. So fg of x prime. How do I differentiate a product of two functions? Okay, let me tell you again. 1 prime times 2 plus 1 times 2 prime. This is the 1, and this is the second. So what do I have to do? F prime times G, very good, plus F, it's a product, yes, times G prime. Excellent. So now I can replace and say Fg of 3 prime will be then what? F3 times plus excellent. Very good. In the ratio. But this is the product. I haven't gotten to this one yet. I'm working on that one yet first. When I get to this one, yes, I will have the denominator, I will have minus here, and I will have over g squared of 3. Completely agree. Okay, so then, now I go back to the problem. I am told f prime of whatever you want is 2. So then how much is f prime of 3? Times g of 3. Negative 1 right here. Plus f of 3 times g prime of 3. Negative 2 plus 20, 18. So the rate of change of this product of two functions at x equals 3 is 18. Moving on. Now let's work on the ratio. F over g prime. What does this equal to? The rule is different. And we proved it today with somewhat difficult algebra. So what is it? F prime times, it's the same with the product, but minus at the top, and it has a denominator, and the denominator is over g squared, not different. I know you didn't say that, but I'm just emphasizing. It's not g prime, but it's g squared. Excellent. Good. So now, from here, I can find f over g at 3 prime. Should be outside. So please tell me what to write, because this was for x. So first of all, let's see this for everyone to see. Very good. So now we're ready. F prime of 3. 2. G of 3. F of 3. G prime of 3. Over G of 3. So then the top is negative 2 minus 20 over 1, which is negative 22. Any questions? Any questions? Are we okay? Okay. Let's look at C, and then we can come back to B. Let's look at C. We're given y equals x to the fourth plus 2e to the x. We are given a point, and we are asked to find the points on the graph of this function where the tangent is parallel. Find equations of the tangent line and normal line to the graph of this at 0, 2. The normal line, let me explain what the normal line is. So let's look at the curve. This is curve C. And let's say at this point I have a tangent. And this is point P, and this is the tangent at P. The normal line is the line that is perpendicular, so normal line. The line that is perpendicular to the tangent line at that particular point. It passes through the point and it's perpendicular to the tangent line at that point. So, one more time, I'm asked to find equations of the tangent line and the normal line to the graph of this at point 0, 2. I know that the tangent will be y minus y1 equals the slope times x minus x1. And I have 0, 2. But the question is, how do I find the slope? I find the derivative. So I find y prime. What is y prime? Excellent. Here's how I evaluate if I'm talking about y prime. Here's how I write the value of y prime at the point. Y prime, a long bar, a vertical line if you want, x equals 0. And then I put the answer. So this says that I'm evaluating the derivative at x equals 0. How do I do that? And how much is it? 2. So then the slope is 2. So then y minus 2 equals 2 times x. Or y equals 2x plus 2. Any questions?
Is there a name for that number?
Which one?
The one that says you evaluated at.
This is how, if I have f, then I write this. But if I have y or y prime, I have to write this. I cannot write y prime at x equals 0 or something like that. Yeah. Perfect. So I determined the equation of this line. So this is y equals 2x plus 2. The point is 0, 2. Now I want to determine the equation of this line. How do I do that? Yes. So if the slope of the tangent is 2, the slope of the perpendicular line on that tangent is the negative multiplicative inverse. Well done. Negative 1/2, indeed. So then the equation of this line, the green line, which is the normal line, will be y minus y1 equals the slope times x minus x1, where the slope is negative 1/2 and the point is still the same because both go through P. It's just that the slope is different. So then what do I do next? Well, it's y minus 2 equals negative 1/2 times x, x minus 0. So I have y equals negative 1/2 x plus 2. So this is the normal line, and this is the tangent line. Of course, both of them are at P. to the graph of the function or the curve, but at P. Questions? Questions? I still have time. The equation of motion of a particle is given below. Let's see if this is interesting to you. If not, we can come back later. Find the points on the graph where the tangent is parallel to the secant line through x equals 1 and x equals 4. Yes? Very good. So let's work on this problem then. Okay, so we have f of x equals x cubed minus 2x, where the tangent is parallel to the secant line through x equals 1 and through x equals 4. Okay, here's the scenario. Here's the idea. Let's say I have this function. I have a point here. Let's say point A with x equals 1, and I have here point B with x equals 4, and this is the line that is secant line, and I'm asked to find, it says the points or points on the graph where the tangent is parallel to this line. So let's say I have one here, and I have one here. So at those two blue points, the tangents here are parallel for sure to this line. So how do I determine those points? What would you recommend doing first? Okay, I find the derivative. So this is very good. I found the derivative. Okay, then
X. What's the slope of the secant?
I have to find the slope of the secant line. Right. So I have to find the slope of the secant line, AB. How do I find the slope of the secant line, AB? What am I missing?
This is the alpha, which is only 1.
Very good. 1 minus 2 is? And here? 64. So f of 4. 4 to the third. 64 minus 8 is it 56? Okay. Now I can find the slope of the secant line. Tony, are you okay?
Yeah, okay.
Okay, so what is it? Very good, excellent. Very good, excellent. So y2 minus y1 over x2 minus x1. Very good. So the top is 57, the bottom is 3. So when I divide, I get 19. Good. So I found the slope of this line, which is 19. Then the slope of this line is 19, and the slope of this line equals 19. So what next?
You have to find out what x value the slope is.
Exactly.
19 equals 3x.
Very good. I have to solve the equation f prime being 19. So this is the equation that we have here. F prime of x equals 19. This is what I need to solve. Very good. So I have 3x squared equals 21 because I'm adding 2 to both sides. What happens next? So x squared equals 7. What happens next? Take the square root, and then x equals? Exactly. 2 solutions, quadratic, plus or minus the square root of 7. So there is a point here that I'm going to call P, and there is a point here that I'm going to call Q. So P has coordinates, Q has coordinates. we are asked to find the points. We're asked to find the points on the graph. So what is the x-coordinate of P?
So root 7.
Very good. And what is the x-coordinate of Q?
Negative.
It doesn't matter. I should have put negative here because I showed it on the left. Doesn't matter. So now how do I determine the y-coordinate of P and the y-coordinate of Q? Exactly. I'm just going to write just that. Here with minus and here with plus. And these are the points. Any questions? Any questions? Okay. The equation of motion of a particle is given below, where s is in meters and t is in seconds. And I have s of t equals t cubed minus 3t. Find the velocity and acceleration as a function, yes, as functions of t, that's correct. I thought I missed something there. Find the acceleration after 1 second, and find the acceleration when the velocity is 0. How do I do that? So I have s of t, which is t cubed minus 2t. I'm asked to find the velocity as a function of t, v of t. What is the velocity? If I have, right, the velocity is the rate of change of distance with respect to time. So it's s prime of t. How much is that? Very good. Now I'm asked to find the acceleration. Very good. The acceleration is v prime of t or s double prime of t. But since I have the velocity already, what will be the acceleration function of t? Very good. Excellent. So that was the first question. Find the acceleration after 1 second. Measurement unit.
That's meters per second squared.
Very good. Acceleration is meters per second squared. Excellent. Good. Find the acceleration when the velocity is 0. Right. So I have to set 3t squared minus 2 equal to 0. How do I solve this equation? What type is it? It's quadratic. How do I solve it? Very good. I isolate x squared, or t squared in this case, in d 2/3, and then, right. In this particular case, I will not put plus or minus. Why I will not put plus or minus in this case when I solve for t? Because it's time, yeah. So it's the square root of 2/3 seconds. Good. So the question was asking us to find the acceleration when the velocity is 0. We found the time where the velocity is 0. And now I'm asked to find the acceleration at that time. Exactly. So acceleration at the square root of 2/3 is nothing else but 6 multiplied by the square root of 2/3. Measurement unit again? Meters per second squared. Any questions? Any questions? Any questions? I wanted to ask you to go back to the test. As I said, I will post the solutions, and I would like you to next time turn in 5. I'm not finished, so don't start packing. So I would like you to turn in 5 problems from the test with Maple. And I will add 5 points if that what you present is correct. I will add 5 points to your test grade. choose. You cannot choose the same problems. Make sure you don't share which problems you choose with anyone else in the class. Choose 5 problems. It can be limits. It can be whatever else you decide. And use Maple for 5 extra points. And turn it in on Wednesday. Okay, so let's go back. At what numbers is the following function differentiable or not differentiable? Give a formula for g prime and sketch the graphs of g and g prime. So we have a function that is g of x, -1 minus 2x for x less than -1, x squared for this, and x greater than 1. So first of all, at what numbers is the following function differentiable? Give a formula for g prime, and then sketch the graphs of g and g prime. So we could start by graphing it. That's a possibility. I have to discuss continuity. If you don't, that's one option. I would not graph it personally. I would discuss continuity first. I would check what happens where, at which points, or x values. Exactly. I will see whether the function is continuous at those points. And if it is continuous, then I will move ahead and talk about differentiability. If it's not continuous at the one or both, then I will say at those values the function is not differentiable. And I will go ahead then and graph the function and its derivative. Okay? So let's talk about continuity. Back to the handout. Here's the definition of continuity. You have all the summary, as I said, except the 11 limit laws. You have everything in chapter 2 in here. So I'm looking for the continuity. That's 2.5. Where is 2.5? Right here. So please remember, this is continuity at the point. The limit from the left equals the limit from the right equals the function value at that point. In other words, the function is defined at A, or exists at A, or A is in the domain of f of x. Limit of the function from either side of A exists, and limit of the function from either side of A equals the function value at A. Okay, so I can say -1 minus 2x continuous on -∞ to -1 as a Pauli function. I would say x squared continuous on -1, 1. I cannot include those points because I haven't checked what happens at those points, as we know, for the same reason as a Pauli. And x is continuous on 1 to infinity as for the same reason. Once I have that established that it's continuous everywhere, but I haven't checked -1 and 1, then I will say continuity at x equals -1. What do I have to write for continuity at -1?
So then as x approaches -1 from
Which branch?
-1 minus x.
Must equal, we don't know that yet.
Must equal to then x approaching the right x squared.
And must equal, we don't know that yet.
G of
G of -1. Very good. Okay, so can anyone give us this limit? Can anyone give us this limit? Can anyone give us this number? Good. So can I say that the function is continuous at -1? Yes. Continuous at x equals -1. Now continuity at x equals 1. What do I have to write or show? From the left, let's start with the left. It doesn't matter really. Which branch do I use for 1 from the left? Very good. Must equal. Limit as x approaches 1 from the right. From which branch? Good. Equals. Should equal g of 1. Good. Can anyone give us this limit? Can anyone give us this limit? Can anyone give us this? G of 1 is 1. So is it continuous at 1? So what do I conclude about G? Everywhere. Very good. G continuous on negative infinity to infinity. Everything. Good. Does this mean that the function will be differentiable everywhere? I don't know. It doesn't mean that. I have to check. So for now, I will give a function that represents the derivative, but I cannot discuss those points at negative 1 and 1 yet. Can anyone give us the derivative of this? Negative 2 indeed. For x less than negative 1. Can anyone give us a derivative of this? For negative 1, 1. Notice that I did not include this and I did not include this. I don't know yet whether the function is differentiable at those points. I know it's continuous at those points. Okay, and now the derivative of this, 1, for x, greater than 1. Greater than 1. Perfect. Okay. How do I show now or check now whether the derivative, I know I have 9 minutes left. We'll finish this. So how do I check now whether function g is differentiable at negative 1 and later differentiable at 1? How do I do that? So let me explain. Unique tangent. This is the trick or the answer. Not trick, an answer. So what is the derivative again? A limit, right? Good. So the limit from the left of negative 1 from negative 2 must equal the limit as x approaches negative 1 from the right of 2x. For g to be differentiable at negative 1. Why? At negative 1, if the two tangents, if this tangent is negative and this tangent is positive as I'm showing them as a corner, there is no unique tangent at this point. So what is the tangent from the left? What does it equal to? What is the tangent from the right? So can I go back and say, yes, this function is differentiable at negative 1 and I can put it back in. I put it back. Because there is a unique tangent. We're going to graph both. We may not be able to graph them today. We'll see. So the slopes, even if there is some sort of thing happening there, the slopes are the same. So there is a unique tangent at that point. Okay, so now let's try the other one. So for the other one, I'm checking whether what? Can anyone dictate? Of 2x, yes, as x approaches 1 from the left, if it equals limit as x approaches 1 from the right from what? 1. What does this equal to? Very good. What does this equal to? They're not the same. So what do we conclude? Right. So the function, although it's continuous everywhere, it's differentiable at negative 1, but it's not differentiable at 1. So when we get the chance to graph the derivative, there will be a jump in the derivative, not in the function. There will be a jump because the left-hand side is 2, the left hand side for u is 2 and the right hand side for u is 1. So this function, the derivative, is not continuous at 1. It will not be continuous. One side is 2, the other side is 1. So the derivative on one side is 2 and the derivative on the other side is 1. Therefore, g is not differentiable at 1. So I can write that. G of x not differentiable at x equals 1 because there are 2 tangents in there, not just one. We accomplished a lot tonight. Let's see what is left from here for Wednesday. We're gonna finish this. I'm gonna graph the function up here and the derivative down here, so you can see them one on top of the other. So for the same values of x, where the function is and where the derivative is. So that's why I had this big grid there. Then we're going to look at something like this, like we did with continuity. Then another application of derivatives. Again, another application for this function. And then I would like to look at this problem. Although it's on homework, I would like to do it with you. So what I would like you to do is pick 5 problems from the test and turn them in with Maple, print it out for me, and then work on these problems. If you have any difficulties, please make a note and say, I want to work on this. You should have almost everything. Definitely from 3.1, everything should be done. So I have a few more examples to show you from 3.2. Yes, please, so you can ask questions.